Welcome to our presentation. Today we present you MediFlow, our solution to the challenges proposed by Hacknosis. Before we delve into the specifics of our project, we would like to address the motivations and objectives kept in mind while we are doing this project. Our motivation stems from a commitment to improving healthcare, and we believe in accessible, efficient, and patient-centric healthcare. So, Hacknosis is focused on bridging healthcare gaps and leveraging innovative solutions resonates with us deeply. And by harnessing the power of technologies such as the OpenText API, we hope to create a positive healthcare experience that empowers both doctors and patients alike. With this motivation in mind, we are committed to optimizing patient experiences by creating an efficient, streamlined workflow that reduces patient wait times and human errors. For the challenge, we chose data analysis and presentation in doctor portals. We chose to tackle this challenge because physician workflows play a pivotal role in shaping the patient experience. Data analysis and visualization are crucial parts of the physician workflow. So by addressing this challenge, we can create a doctor portal that streamlines access to patient information. Not only does this reduce patient wait time, but also provides physicians with sufficient insight for informed decision-making. For example, leading to more accurate diagnoses and treatment for patients, minimizes human errors, and ensures timely follow-ups. For example, doctors could book new appointments here. Now let us present you an overview of MediFlow. There are three main sections: the login authentication page, dashboard of patients, and individual patient charts for each patient listed in the dashboard. Details about how these sections are implemented as well as interacted with will be demonstrated in the demos.
I will be walking through our tech stack used for our front-end application. So we're using Figma for UI UX design so that our application is easy to use. And along with that, our framework is Angular. We use the Angular material to create an UI that is visually appealing and easy to use for the users. And moreover, we have integrated the Brava viewer provided by OpenText to view our text medical reports. And in the future, we're planning to deploy through GitHub Actions to Firebase. For our backend, we are mostly using Spring Boot as our web server, which is also documented by OpenAPI Spec, or also called a Swagger UI. And then we use incorporated Spring security functionalities to ensure secure HTTP requests, and also the endpoints are protected with role-based access model. And moreover, we are using Spring Data JPA along with MySQL database to store a bunch of metadata for our users and patients, as well as medical reports. We also incorporated functionalities, services provided by OpenText, including the content storage, which allow us to upload our actual medical report file to their cloud server, and which also supports virus scan. We're also using their transformation and the viewing services, which is connected to our front end for to get our Brava viewer up working. And we're also using Amazon Comprehend Medical service to provide textual insights to any textual reports, doctor notes, and all prescriptions, such, etc. And we also been using Gmail's APIs on Google Cloud Platform to provide a live notification for live email notification for users once they have an appointment that's coming up or it has been updated. For our AI engine, we are using Django as our server, which accepts image medical reports, and we pre-process it to make it clearer for doctors to view. So the training, to create the training set, we're using Torch.io to apply some random transformations like random motion, random noises, and random blur on our sample data set, so to make it more robust, so it aligns with um, real life cases. And the neural network that we're using to deblur and denoise the image is powered by PyTorch. And also there's some traditional OpenCV tasks being implemented. So we basically trained that model so it fits our use cases. Here's an overview of how our AI engine is functioning. So for the training phase, we have a bunch of raw data that's coming in, and then we pair it up with transform dataset, which is went through the Torch.io, that during which we applied random transformations. And then in our neural network model, we applied a few algorithms, and then we evaluate its performance in each of the iterations, and we will save the best result as our trained model, which we will be using later in production. So in production, some real medical data that might be blurry or uh, some random motions in it, we will pass it through our trained model, which is powered by PyTorch to process the data so it's clearer. Here's our software architecture diagram. So the end user will mainly interact with the web client, the Angular web application directly. And the Angular application will interact with Spring Boot web server. In the middle, we have web interceptor. So we imposed the JWT authentication and user session management. And the web server will interact with the MySQL database for storing and basically querying data. And then it also communicates with OpenText services through OAuth2 sessions. And the web server also interacts with the AWS services, the Medical Comprehend service, through their provided secured client. And finally, when we process any reports, we will image reports, we will communicate with our Django server behind the scene using REST API. And finally, we are using GitHub for our remote code repository. And in the future, when we want to deploy to maybe Google Cloud Platform, we will be using GitLab CI/CD pipeline, as well as Docker as the image container.
Here are some benefits of our approach to this challenge. We anticipate increased doctor productivity and diagnosis accuracy because doctors could take advantage of the key insights captured from textual reports and a clearer medical image from pre-processing. There will also be reduced human errors caused by external factors such as bad medical image quality and intricate prescription notes. Patients will also enjoy better experiences and follow-up treatment with the shorter wait time, more accurate diagnoses, and live notification for updates on appointments. Finally, there will be a streamlined medical image pre-processing to improve workflow.
So for some future enhancements, we are thinking like deploy our microservices to prod. We plan to build a GitLab CI/CD pipeline that automates the unit tests and some infrastructure as code, so we don't have to manually provision the resources on the cloud providers. And we'll be using Docker as our application container. And then we will deploy our front end to Firebase or Vercel, either one, and which is also integrated into our pipelines. For backend, we plan to deploy it as a Cloud Run service onto Google Cloud Platform, along with Cloud SQL integrated using service accounts to automate this processing the pipeline. Similarly, for our AI engine, we will also deploy as cloud service. And another big improvements we are planning is we want to enhance the medical image processing using maybe convolutional neural network and supports image segmentation. Also locating some region of interest provided by the doctor, so we can apply some qualitative and quantitative analysis on it. And we can also support asynchronous or event-triggered processing. So by using Kafka message queue or the GCP's pops up functionality to ensure maybe some retry policies, and so it's more robust, the report processing flow. Furthermore, some performance improvements we are thinking is to incorporate Redis to compensate for frequent query of resources. So querying of medical images, textual report, and stuff like that.
In conclusion, MediFlow not only represents a technological innovation, but also proposes a step towards transforming the physician workflow to optimize patient experiences. As we move forward, we are dedicated to making the vision of accessible and data-driven healthcare a reality. With the future prospects in mind, we hope to expand on our current project and develop more effective systems to achieve our beliefs. Thank you for joining us on this journey.